Welcome again. So we'll look at the second problem from your mini assignment. And the problem here is there's a student in this class who has chatted with exactly one other student. First thing, I'm asking you to create a domain here. So I'm going to say, all right, my domain here is of students in the class. So I'm not looking at every single out there. I'm not looking at every single student out in the domain. I'm looking at only those students that happen to be in my class. Okay, so given that domain here, let's think about a predicate. So my predicate, my predicate is going to be C of x comma y such that person X has chatted with person Y. Okay, now how would I put the entire proposition logic such that there's a student in this class who has chatted with exactly one other student? Okay, so now here everything on the left is for my explanation purposes. So let's say this is my domain of every single student in the class. There's student A, there's student B, C, and let's say D. And let's assume that A has chatted with C, A has chatted with B, B has chatted with C, and D has chatted only with A here. So I did this intentionally right now just so that we can answer this question here and kind of get an intuition as to how I'm going to put my solution together. So I will say given this domain of all students here, it's obvious that the student that I'm looking at, so this again, let's just set overdose of yellow here, so let's put some orange, A, B, D, and C. Okay, the student here is D. There's this student D that has chatted with exactly one other student. D has chatted only with A. A has chatted with B, A has chatted with C, B has also chatted with two people here, C has chatted with two people here, it's only D that has chatted with one person here. So what I'm going to say here is in my solution, let's say there's some X out there that you don't know. In this domain happens to be D. There's some X out there, and there's some Y out there, such that let's just make sure that these guys are not equal to each other, such that X is not equal to Y. Okay, just what I've put so far in orange here gives you some X and some Y such that they're not equal. It could be A and C, could be A and B, could be A and D, B and D, B and C, as long as they're not equal. Okay, if this holds, then for all Z, again, in this entire universe Z, such that, okay, I don't have space here, so I'm just going to put it over here, such that Z not equal to X. As long as you can pull one such, so from this entire universe of Z's here, give me one Z that is not equal to X here. So let's put some values here. Let's say this X that I've chosen, first time I've chosen this X here, happens to be D. And the Y that I've chosen here, let's say this happens to be A. So X not equal to Y, well, X is D, Y is A. They're not equal right now. And for all Z, such that Z is not equal to X, so this could mean that the Z's that I'm looking at right now is A, B, or C, right? I'm just looking at A, B, or C. Okay, so if Z not equals to X, if this holds, then Z equals, if Z equals to Y, then I'm using a bidirectional operator of X comma Z, and I'm going to explain this in a few moments. Okay, what does this mean here? It means that if Z equals to Y, then C of X comma Z, and if C of X comma Z, then Z equals to Y, because I have the bidirectional operator. Okay, what does this even mean here? What is happening? How does this piece in orange map to what the question is saying? Okay, so what does this entire thing mean here? What this means over here is that get me all the list of students here for all Z's, such that these students are not equal to X. X happens to be D, so all these students that are not equal to X are A, B, and C. Then, if Z equals to Y, then C of x comma z, and if C of x comma z, if x is chatting with z, then z must be equal to y. Okay, so let's think about this. If z happens to be a, x over here happens to be d. Both are not equal, and if both are not equal, what that tells you is that if z is actually equal to y, if z is equal to y, and y happens to be right now a, if both are equal, then that implies that x is chatting with z, and x is in this case d, and z happens to be in this case a. So d and a are chatting with each other, which I can see that a and d are chatting with each other. And if x is chatting with z, if d is chatting with a, then it also implies z equals to y. That's the meaning of the bidirectional operator, which means that if I have something like this, the bidirectional operator, it means that's what it implies. Okay, and you can check this for yourself that when I go for across every single student, because I'm going for all z's here, when I go across every single z over here, this box in this box in blue is going to be true, is going to be true for every single z. And this entire expression will be true when you have found one such x which happens to be d, one such y which happens to be a, and you've gone across every single z for which this entire box blue is true, and this works out completely in this entire universe.